Okay, good morning everyone. So myself Devabroto Das from Domka Engineering College. Today we will take the subject control system. Our topic is gain margin, phase margin, and M circles and N circles.
Am I audible?
Yes, sir.
Okay, so just wait. I'm starting.
Yes, sir.
Yes. Okay, so last classes we have discussed in our stability control system. This is the gain margin and phase margins also. Okay, and there are other topics is also available in our stability analysis in our module 4. This is the basically M circles and N circles also. Okay, so little bit we have to recall and then we have to continue our new topics also. So my whiteboard is visible, all of you?
No, sir. No, sir.
No, okay, just wait. Right now it is visible?
Yes, sir.
Okay. So first we have to discuss gain phase plot. This is also related in our Nyquist criteria and as well as also gain margin and phase margins also. So last classes we have to discover that is the gain margin. That is expressed, that is G dot M, that is the gain margin. Is it equal to 20 log 10? This is 1 by magnitude, that is mod of G j omega 2 H j omega 2, and it is the unit, that is the dB, that means the decibel. We have learned, and another one we have to learn, that is the phase margin. This is PM. This is equals to 180 degree plus angle of magnitude, that is a G j omega 1 into H j omega 1. Okay, so these are the basic two things we have to learn in our previous classes, gain margin and phase margin. And here you have to know that is omega 2, it is the phase crossover frequency, and omega 1, this is the gain crossover frequency. Okay, and then we have to continue the gain phase plot. So in the figure, just wait, I am drawing a figure. This is the real axis and this is the imaginary axis. Imaginary axis, and this is the real axis. This is the unit circle. That means when you have to draw the circles, something like that, this is the basic circle. So little bit it is also increases. Something like that. This is the circular structures. Okay, and this is the polar plot of the figure. This is starting, then the negative, and then intersect the circle. This is the another part. And here the omega, it is the infinite range, positive of infinite range. This is the basically value of -1. Okay, and where the polar plot, it is the intersect the real axis. This is the basically omega 2, and we know that omega 2 is the phase crossover frequency. This is the omega 2, and this is the unit circle, and this unit circle, it is intersect a point, this point. This point, it is expressed, that is the omega, that is the omega 1 also. This is the basically gain crossover frequency. Okay, so this is the basically diagram, that is the figure A. This is the polar plot. For stable system. Stable system. Okay, and this is the basically plane of G omega H J omega plane. Okay, so when you have to draw the one stable system in the polar plot of the stable system, this is the basic structures we have to discover here also. Okay, so this is the unit circles, and these unit circles, it is intersect at one point. This point, it is expressed here also, omega 1. This omega 1 we have to call gain crossover frequency, and where the positive range of this is the unit circles, these are the basically omega 2. This is called the phase crossover frequency in the stable system. And when this stable system we have to draw the polar plot, this value, it is less than, that is a less than 1. This is the basically stable system. And when another pictures we have to draw, this is the real axis, this is the imaginary axis, and this is the real axis. And when you have to draw the unstable system, the structure, it is coming like something like that. This is the basically structures, and this is the unit circle. When you have to draw a circle in the point of center point, something like that, this is the unit circle. Okay, and here the maximum value of omega, it is positive of infinite, and this is the basically -1 point value. And when a unstable system we have to consider in the polar plot system, the graphical structures we have to consider from these patterns also. And this is the rotations of the also clockwise direction. Is it also same? This is the clockwise directions. Okay, so this is the unit circle, and where the unit circle and polar plot, it is intersect a point. This is the omega 1. This point, it is also omega 1, and this point, it is called the gain crossover frequency. Okay, and when this polar plot, it is intersect the real axis in this point, this is the omega 2, and this is the called the phase crossover frequency. Okay, so this is the difference between the polar plot for stable system and unstable system. So figure B, this is a polar plot for unstable system. And also it is draw the magnitude of the plane. This is G j omega into H j omega plane. Okay, is it okay, all of you? So here you can see two diagrams we have to discover here. One is the stable system where the polar plot it is less than the 1, and another one it is the unstable system where the polar plot it is greater than the 1 this point. So that is the basically difference between the polar plot in the stable system and unstable system. So we conclude this point. So that means figure A, where the magnitude that is G j omega H j omega at the phase crossover frequency omega 2 is less than 1. Hence the gain margin is positive. Also, the phase margin is also positive. Phase margin is also positive. So, therefore, the system is a stable system. The closed loop system is stable. So please remember these two things. First one, that is a figure A, where we have to draw in the previous diagram for the stable systems. So here, magnitude of the G j omega is j omega at the phase crossover frequency, that is the omega 2. It is less than the 1. Hence this position, it is gain margin, it is also positive. And then gain margin, it is also positive. That means the phase margin, it is also positive. So that the system, that is the closed loop system, it is also stable. Another one we have to consider, that is the figure B, the magnitude also G j omega and H j omega at the phase crossover frequency that is the omega 2 is more than 1. Is more than 1. Hence the gain margin is negative. So the phase margin, it is also negative. Is also negative. So therefore the system, it is unstable. Closed loop system is unstable. So please remember these 2 points also. So this is a very important. So when the phase crossover frequency, that is omega 2, it is less than 1, then the gain margin it is also positive, as well as also phase margin it is also positive. So that means the closed loop system it is also stable system. And another one, when the magnitude of the phase crossover frequency, that is the omega 2, it is also value is more than 1. Hence this gain margin at this point is also negative. That's why the also phase margin it is also negative. So that's why the system it is called the unstable system also. Okay. So now this two figure in the previous diagram, figure 1 and figure A and figure B, we have to plot it the gain phase plot. So that means the picture is coming next. The gain phase plot is a graph between the gain, and here the gain is we have to consider the magnitude. That means magnitude of Gj omega into Hj omega in decibel. And the phase of the magnitude, that is the also Gj omega and Hj omega, we have to consider here for the phase plot system, that is the gain phase plot. Okay, so now we have to plot it the diagram in the gain phase plot. The diagram is coming. So first you have to draw this one, then another. We have to cross section this line also. Okay, this is the gain crossover, that is the gain phase plot. We have to plot it here, and here the angle, this is the minus 270 degree, this is the minus of 180 degree, and this is the 90 degree. Okay, and this is the 0 dB, and here the value of magnitude is Gj omega Hj omega, also mod of, and it is expressed in the decibels also. So when a stable system, you have to draw the gain phase plot according to the gain margin and phase margin. The diagram it is basically coming in that pattern. So just wait, I am drawing. Something like that. Okay, this is the direction of the omega. This first intersect point, this is the omega 1, and second intersect point, that is the omega 2, and this intersect point, this distance, this one and this one, it is the gain margin, and here also intersect this axis also, and this is the express of the phase margin Pn. Okay, so please remember these things when you have to draw the gain phase plot, and it is graph between the magnitude of the system, that means the Gj omega, sorry, Gj omega and Hj omega. Angle of magnitude with respect to, that is the Gj omega, Hj omega plane also. Okay, this is for the stable system. Another one, when you have to consider for the unstable system, so diagram is coming. Next, another one. Then we have to plot it the first, then second. Okay. This is same angle of magnitude, that is the 270 degree. This is the another one minus 180 degree, and this is the 90 degree. Also, this is the 0 dB. This is the higher magnitude of the gain phase margin. That is also J omega, right? J omega. So when a system it is unstable, the pattern is coming. Just follow that. These patterns also. This is the direction. This is the omega. First, this point intersect the line. This is expressed omega 2, and another one intersect the axis, that is the omega 1. And this point, this distance, it is called the phase margin. Another one to the axis, this is called the gain. Also, this is the negative, and this is the also negative. And here the phase margin, it is also positive, and it is also gain margin, it is also positive. So these are the basically difference between the stable systems and unstable system. And here the angle of magnitude is the J omega, J omega. So here you can see these are the basic difference between the stable system and unstable system. Is it clear, all of you? So first figure, this is the figure A, and this is the figure B. This is the gain phase plot for stable system. Another one, this is the gain phase plot for unstable system. Is it clear?
Yes, sir. Yes, sir.
Okay. So one important question, it is coming in your semester question paper. What is gain phase plot? And draw the stable or unstable system for the gain phase plot. Okay. So we have to discuss all things. Next. Next, we have to consider one closed loop frequency response analysis for the Nyquist plot also. Just wait. Next topic is closed loop frequency response of a unity feedback control system unity feedback. That means here the feedback factor, the value it is 1. Okay, so feedback system from Nyquist plot. This is another one important term. How it is calculated? So the question is, a closed loop response, closed loop unity feedback system you have to given. So you have to calculate the closed loop frequency response of a unity feedback system from Nyquist plot. Okay. So in the previous diagram, first I am draw the one stable control system. So this is the real axis and this is the imaginary axis. Everyone please practice this image, that is practice this diagram in your rooms, because this diagram, it is very important for your practices. Okay, so and you have to practice this more and more, and then आप लोगों को ये आदत हो जाएगा. So this is the imaginary axis and this is the real axis also. So here we have to consider for the stable system, for the closed loop control system. So when the stable system you have to consider, that means the polar plot, it is around the between the less than 1. We know that, something like that. Okay. And the unit circle, this is the circle. So little bit consider me, this is the also circle pattern, but in the whiteboard using this pen it is not properly circulated. Okay, but you have to consider this is circular. Okay, so this is the clockwise direction, and this point, it is the intersect between the unit circle to the polar plot system, and this point, it is the -1. So when the plot, it is less than the 1, that is the -1, then the system, it is called the stable system. We know that. So here omega, it is the positive of infinite range, and intersect area, just consider me, this is the basically connected this point also, and another one, it is also connected this point also. Okay, now we have to give the name. This is the O, and this point, it is the A, and this sector point, that is the P. Okay, so here you can see this is the one triangle we have to make. So that this angle to the real axis, we have to express here, that is the alpha. This is the alpha. Okay, and this angle, that is the angle between the axis A and axis this OA and OAB, this is the theta. Okay, and this is the basically value of, that is the omega, and this is the, this is the circle between, this is the polar plot system, and this is the rotation of the clockwise direction. This is the unit circle. Okay, so this here you can see this OA, I'm written here. This OA, this is a basically vector sign. Okay, this is the -1. Another one, that is the OB. Here we have to express, that is the magnitude of the controller, that is the GJ omega, and AB, this AB, here we have to consider mod of 1 plus GJ omega. Here feedback loop, it is not present. Why? Because here you can see this is a unity feedback system. That means the HJ omega, that is the value of is 1. So that's why we have to not written here, that is 1 plus GJ omega. Okay, so when the unity feedback system, that means the HJ omega, that is a 1. So we have to consider the transfer function, and here transfer function we have to express, that is M. We know that that is the CS. But when you have to consider for the polar plot, we have to express that is the j omega c j omega by r j omega. So this is the transfer function ratio. It is the ratio between the output response to the input response. Okay. So now you have to put this value. What is the transfer function of this given diagram? So this is the Cj omega by Rj omega. We know that that is the Gs by 1 plus Gs and Hs, but Hs, that is the value it is, that is also 1. So that's why we have to written that is Gj omega by 1 plus Gj omega. Okay. So here the value of that is a OA, that is a -1, a OB vector, that is a Gj omega. So we have to easily calculate it. That is the AB. It is difference between the 1 minute. It is difference between the OB minus OA vector. So value is, you have to put it here. So OB is the, I think, Gj omega minus of OA, that is the -1. Okay. So we have to calculate, that is the equation is coming, I think, 1 plus G omega. So this is the value of AB. Okay. Now you have to put this value. That means we have to return the complete equation. That is the transfer function, that is equals to Cj omega by R j omega. This is equals to, we know that Gj omega by 1 plus Gj omega. So this is the value of Gj omega, that is OB vector. So we written here, that is the OB vector by this one. This is the also 1 plus J omega, that is the AB vector. So this is the AB vector, and with respect to, we have to consider here one of it. Okay. Up to this part, it is clear, all of you? This is very simple.
Yes, sir.
Okay. Next, we have to calculate the angle of magnitude of this closed loop system. So with respect to, that is the angle of Cj omega by Rj omega. So also this is the angle between the two things. First one, angle OB vector, another one, angle of AB vector. And here in the previous diagram, we have to express here angle of OB, it is the alpha. Another one, angle of AB, we have to express here theta. And also we have to return, that is the difference alpha minus theta. Okay, is it clear? Here you can see this is the basically diagram. The alpha is the angle, it is between the this center point to the AB OB axis to the real axis also. Another one, this is the angle of theta, it is intersect between the real axis to the AB point also. So that's why you have to calculate it. Angle of the system, this is equals to angle of difference between the alpha minus theta. Now this is the one equation, equation 2, and the previous equation, this is the complete transfer function. This is the equation 1. This is the angle of Cj omega by R j omega. So written that as per equations 1 and 2, the equation given below, obtain, this is Cj omega by Rj omega, we have to return, that is m e to the power j phi, where the phi is, sorry, this is phi, this is difference between the alpha minus theta. Okay, so the magnitude of Cj omega by Rj omega, this is the system, is given by m, this is the transfer function, and the phase angle, that is the phase we have to express here, that is phi. Okay, so this graph between a graph between the magnitude of the system, this is Cj omega by R j omega, and the omega. Okay, so this is the basically closed loop system frequency response analysis for the from the Nyquist plot also. Okay, is it clear, all of you? So everyone please write your own name and roll number in the chat box also. Gautam is present. Gautam, are you hearing me?
Yes, sir.
Okay.
Yes, sir.
Okay. So you take a screenshot of the participant list.
Okay, sir.
Okay. And we have another class. So after ending this class, all of you please join. And this next class we have to discuss another important topic, which is you have to change your syllabus. This is the M circles and in circles. This is the last thing topics we have to discuss in our stability analysis of control system from your syllabus. And after that, the module 4, it is also completed. Next classes, the next day also we have to consider our next another module. I think last module, that is the compensation network also. Okay. So up to this part, anyone any doubt or any questions, so please ask me. And everyone, please write your own name and roll number in the chat box also. Very quick. Next is constant magnitude. That is M circle. Okay, so everyone please join after 2 minutes. Okay.